Hi, everybody. Welcome back to Science with Marty. This is Marty. I'm Corey. Marty's the scientist. I'm here to help out.
Corey's our technical specialist.
Yeah, and I don't know as much about science, so I can help you guys at home ask questions.
There you go.
As always, if you guys have questions, down at the bottom of your screen is the Q&A box. You can click on that and type your questions in, and I will help you ask Marty what you want to know.
Okay.
Yeah.
I have a lot of things to show you today. We're going to talk about things that go. That's the theme. So there are a lot of things that you do not have handy around the house or handy where you're watching where you'll be able to do this. However, you'll be able to see this video at
YouTube. Within a few days of each class, the recording of this webinar will be up on Delphian's YouTube page. So we're going to show you lots of projects today of like fun things that you can make at home. But Marty has so many things that he wants to show you. We didn't want to even tell you to like run around and get this stuff. So instead, you'll be able to watch the video afterward and pause it and then go look for things and get the stuff to make these projects, but on your own time, because I think you'll want to pause and like look at the little diagrams he's going to show you. But today you can follow along and ask us questions, and you can kind of pick which project you want to work on. Because there's going to be some fun stuff.
If you see something, you say, I want to get that, or I want to do that, then you can make a note of what stuff you'll need and where you can get it and that sort of thing. I'll be sharing with you some places where I got stuff.
Yeah.
So things that go, we're going to talk about work and energy. So work just means moving something. If you use a lot of force and you push on something, but it doesn't move, you've done zero work.
Feels like you've done some work.
It feels like you could be perspiring. You push on the wall all day. It seems like a lot of work, but it's zero work. There has to be motion. So you need distance and force, and you multiply those two things together, you get the amount of work you've done. Energy just means being able to do work or doing work. So you eat food, food gives you energy, you're able to move your body or other things like that. And there are different types of energies. There's food energy, as I mentioned. There's chemical energy, like from a battery. That would be chemical energy. Batteries can, move things around.
Rocket fuel or something?
Rocket, plane fuel, gasoline. All of these are chemical energies. And they're also stored energy. You're not using it now, but it's ready. Whenever you start up that car or that whatever, or get on your bike, you don't have to be eating while you're on your bike. You have stored energy from the food. And
a few comments here from students already. Hi, by the way, everyone that's saying hi. Hi, Evan. Hi, Aubrey.
Hi.
Milo says his sister thinks that science is cool. Your sister is cool,
Me
Milo,
too.
for thinking that.
Science is cool.
Ian says hi. Willow asks, I think Willow just got in here and asks what we're going to do today. Willow, we're going to be talking about motion and little vehicles and things that move today.
Yes.
So, yeah.
Okay. There's electrical we talked about. Things can move because of electricity. And maybe later, if we have time, we'll get a little into nuclear energy.
Awesome.
But right now, we're going to start with our first picture. Corey, do you have that first picture?
Yes, I do.
It is of a clock.
Yeah.
And so that clock looks like that runs on batteries. But if you see the kind that has these two little holes in the face.
Oh, that one has two holes in the face.
It does?
There and there.
Oh, okay.
Yeah.
Good. Well, one is to wind up the spring, like this spring. I don't know if you can see this spring.
Oh, and it has a key on the side right there.
Yeah. So this also has a key. And what this key does is you wind it up and you notice
let me close this for a second so they can see that better.
The spring got shorter. And then when I let it go, it unwinds, and you could probably hear it whirling, but you could also see these wheels spinning. Can you see the wheels spinning? And so this spring is unwinding. So this is stored energy. That's how that clock works. That's an 8-day clock. In other words, you wind up the spring and it gives it enough energy to tick for 8 days.
That's awesome.
It is. We used to have them at home. We used to have lots. My parents collected these wind up antique
Really?
clocks. Yeah, they did.
That'd probably be noisy when they all went off and started making
Yeah,
noise.
it was. Your body can move because your body gets energy from food, and it's stored energy and chemical energy, both. And so you can move around. And here's something interesting that a lot of people don't know. You eat food and it's so many calories. You eat this peach and it has 60 calories, let's say.
Mhm.
Well, a calorie is actually a measure of heat. Now, temperature, Celsius or Fahrenheit, tells you how much there is in the room or in a baked potato or whatever. But a calorie is what scientists use to measure the amount of heat that food has. So when you burn it up in your body, it's giving you a certain amount of energy. And that's what we call calories.
Awesome.
Okay. So we talked about cars moving and gasoline and toys moving and that sort of thing. I'm going to show you, I showed you this wind-up toy, but I have another. Now this one works because of a string. You pull the string, that winds up the spring inside.
Is that what that's actually doing? I've never taken apart a toy like this.
That's what it's doing. It has one of these inside.
Mm-hmm.
And so when you're pulling the string, you're winding up the spring, which is then making it move.
So it's like your motion, you're putting energy into the device.
Exactly.
That then it's going to use.
It's stored energy. A wound up spring is stored energy.
Mm-hmm.
Here's something that I remember from college physics. Energy can't be created or destroyed.
Mm-hmm.
And so if you take a spring and you put it in acid, it'll get eaten away.
Right.
So if you have wound up spring, now there's stored energy.
Mm-hmm.
If you put this in acid,
Mm-hmm.
won't that be breaking that law that energy can't be destroyed?
Does the acid eat through part of it? And
Yeah, the acid will eat the metal.
Mm-hmm. Okay.
But what'll happen actually is with a wound up spring, it'll get hotter. The acid will get hotter.
Really?
So the energy is not destroyed, it's turned into heat energy.
That's fascinating.
It is. Most things on this planet will turn into heat energy when they're used. Okay, now here are some fun things. Some of these things, like this, I don't know if you've seen this. I work with lower school students.
Mm-hmm.
And we were playing with this the other day. We were talking about helicopters, and you can get these things on Amazon and eBay, and they're called plastic flying saucer toys. And you get like 40 sets. That is 40 of these wands, 40 of these little plastic holders that you might see at the bottom here,
Mm-hmm.
and 40 of these rings on there for like $7. So that's
a good deal.
If you're interested, it's fun, and I can take this. And I got tired of doing it one at a time. So I did it 3 at a time just to see if you could do it. And guess what? You can. Oh, hey. So
That's awesome.
This is a fun thing to do. Let's see, how does this work? This is coming down here, and I have stored energy in my body, which I'm changing into motion energy when I push it up.
Mm-hmm.
Okay, so that's how that works.
Awesome.
Okay, oh, now I have gliders. Do you have that glider picture?
Yeah. We have your first of all.
There's
There's an awesome picture of a spring.
Right?
Is this like a spring that actually comes out of a clock?
Yes,
That's a giant spring on the left hand side.
that's why it lasts for 8 days.
So it's like over 8 days, it's slowly releasing
Tick-tock,
that.
tick-tock, releasing that energy. And
Wow.
there's a whole bunch of gears in there, just like there are gears in here. I don't know if you can see those gears in here,
Mm-hmm.
but that's why when I turn this once, this turns, you can see how quickly this is moving compared to how slowly that's moving.
Yeah.
That's what the gears do.
Awesome.
Okay,
And
do
this
we have
next one, that's
there's
another
the
picture
flying
of those twisty flying saucers.
Yeah. And this is the template. A template is like an outline,
Mhm.
and you get a paper plate and you cut it in that template. It doesn't have to be exact.
This, by the way, is one of those spots where when you're watching it on YouTube, this would be a good point to pause so you can go grab these supplies and then you can try drawing this shape and cut it out.
Right. So what I've done here, if I can get this tape off, because I put a little tape on there. There we go. And oh, I have it at the bottom too. Okay, well, I took this piece that was at the back and I folded it and I put it in that little slot in the back. And I folded the nose, has a little nose sticking out the front. And I folded that over and put a penny in there for weight. And sometimes if it flies this way, you need to adjust the penny more toward the other side. If it flies this way, you need to adjust the penny more toward this side until you can get it so that it flies.
You guys can't see this, but it went across the whole room.
It went across the room. And so you could have fun with that. And you could try it with 2 pennies and see what difference it makes. You know,
what is the purpose of the penny in the front?
To weight it down. If you just have all the weight in the back, it wouldn't go properly. It needs weight in the front too. That's why some model rockets you get, they have extra weights you can put in the nose cone so that it'll be balanced.
Interesting.
Yeah.
So if it's too light in front, it might just wobble and it's light.
Right.
Interesting.
Right. Okay, now we're going to talk about balloon cars. Let's see. I have a couple of balloon cars here. I took this one. This is a folded balloon car. And so I blew this up and I let it go and it went about 60 feet.
Wow.
60. This is like a 12-inch balloon. And I just poked a hole in there and put the balloon through, put a little tape on there to hold that angle. Now these wheels, I get these wheels, I don't know if you can see that. These wheels spin around quite easily. And I get them from Kelvin.com that I have on the next page. I don't know if I included it. I think I might have. Next one.
We have
Do I have
picture
it?
of our
Okay, there's a balloon car. Now that didn't use these special wheels, but maybe there's a picture, next picture. Nope. Okay. So anyway,
we can type that in the, we'll show that later.
So you can get this at Kelvin, KELVIN.com. They have wheels like that. You can get them in one color or multicolors, and they're not expensive. They're like $10 for 100 of them.
Now, what scientific property would you say this is using by using a balloon?
Oh, well, this is, again, stored energy. A blown up balloon is stored energy.
But sometimes it can take a lot of work to blow up a balloon.
It can. Now, you might have heard the term potential energy. Potential is just a fancy way of saying stored energy.
Okay.
Just like kinetic is a fancy way to say motion energy. So if something has stored energy, like this blown up balloon, it'll have potential energy. If something is moving, that's kinetic or motion energy. Now these wheels, the wheels I told you about, now if you get a bamboo skewer from the supermarket or wherever you get your bamboo skewers, it might be a little too thick. I get these are 2.5 millimeter bamboo skewers that I got on eBay, but you can get them other places. If you don't get them, if you get regular skewers, you're going to have to take the holes of these wheels and drill them out a little bit with a drill so the bamboo will fit inside and it can spin around easily. And then I just put a little tape on the side so the bamboo wheels don't fall off. And so I have this type, and I have, here's the other one. I have this type. So this is just a simpler model. And what I did is I took a balloon and I cut off the part that has the very end of it that's doubled over. And then I just take the balloon to this. I like to use this cardboard because this is called corrugated cardboard. It has that little space in the middle with it looks like a wave of cardboard, because then the skewer, this wooden skewer, can go right through that little hole.
It just holds it in place.
And holds them in place. That's and
great.
It doesn't move around. And so that's what I like to do. That's why I like to use cardboard. but this is another type. You could try this type of balloon and the other type of balloon and see which one you like, which one goes farther, and play with it. You know, that's how scientists learn things. They do it, they build it, they try it, and they see what works better and what doesn't.
So everybody at home could try their own variations on this too.
Sure,
of course.
I've made those things with cutout wheels from cardboard,
Mhm.
or you could use lid tops or just about anything.
Mhm.
But
See what works the best.
See what works the best. That's
Awesome.
where I like to get my stuff built. Okay, there's also things like this. And this is again your basic cardboard car. And then I used a couple more pieces of cardboard to hold it up, to hold up this piece of wood and a propeller. And you wind up the propeller, and what kind of energy is that when you wind up the propeller again?
Can anybody at home guess? We won't say it for a minute. We'll let you guys type in if you remember. Marty's winding up this propeller attached to a rubber band. What kind of energy is he creating here?
I'm using the energy in my body to make motion energy. And this motion energy is winding up the rubber band, just like it was winding up the spring.
Mackenzie and Denali say stored energy.
Yay!
You guys are right. AG says potential.
Yes.
Katya says stored. Shanna says stored. Everybody's jumping in here.
Okay, you're right.
You guys are all right.
I'm glad
Good
you're
job.
paying attention. Anyway.
Good job, Letica, Jackson, Milo. You guys are on it today.
So
well done.
This is the type of apparatus or equipment you can also get at kelvin.com, Kelvin, and you can see the rubber band is starting to double up over here and get even tighter. And then when you let it go, it goes, it unwinds, and it changes from stored energy to motion energy. There are different types of propellers you can get, and you can put this on a little bit of wood if you wanted. I've also taken paint stirrers. I don't know if you know what paint stirrers are. Do we have any here? No, but I have this. It sort of looks like this, except it's solid. And I've glued on the axles in the front and back and taken a piece of wood and put it in here, and then taken this propeller in the front. And you could use that and see which one you like best, see which one goes farther, that sort of thing.
Nice.
This is one of my favorite things. I discovered this last summer, and I've been playing with it and letting my kids, not my children, my school kids, play with it. This is a 17.5-inch foam airplane that you can get on Amazon. And it's under 10 bucks. I don't know exactly how much it is. And one of the nice things, if I have it like this, and you have a nice open space away from trees, please, because trees eat this stuff. No, they don't eat it. This has a way to get caught in trees, and you don't want to spend some money and then you find you can't get it because it's high up in a tree. So when this is in this position, you see the way that wing is?
Wait, so it has two different spots back
Right.
here. There's a hole back
Right.
here.
There are two holes.
Okay.
So there's this hole. Well, I'll take this out. When you take it out, you have to be careful you don't break it, but you see the two holes? So there are two holes. One is level, that's the bottom one. And then there's this one that's at an angle. And so when it's like this level, it will fly pretty straight. And when I have it like this at the angle, notice I was holding it here to support it because this is the weakest point. And if you hold it back here and try and push it in, it could break here.
Mm-hmm.
So you hold it here to reinforce it, and you push this in or take it out that way. And now if you take it and I hold it at the bottom,
Mm-hmm.
there's no real way not to do this correctly. But if you have a big open field and you throw this, it will do loop-de-loops.
That's awesome.
And I've had elementary lower and middle school kids just play for, time's up. It's 45 minutes. We have to go. Oh no, we want to play. No, yeah, I'm sorry. Time's up. No. So this is a lot of fun, and it's not much money. And again, what does this have to do with stored energy and motion energy? Well, it's the stored energy in my body that changes to motion energy, and the motion energy gets transferred to the styrofoam plane. And this is really pretty unbreakable. I mean, I've had it, crash like that, and nothing really happens to it. And I've had these for a couple of years, and lots of fun. If there's only one thing you get, this is the one.
Now, is it so when you let go of it and it's doing a loop to loop and it's coming back down, is it also using gravity? Does gravity have any connection to energy?
Gravity has a connection. Gravity is a force that's pulling all things down. Mm-hmm. Yes. So gravity will pull it down, but it's so light, and if you give it a good push, that force will keep it up for a while.
Cool.
So this is a fun thing. Okay. Oh, no,
I think we have a picture here in the slideshow of that.
I think
too.
I do.
Oh, we have sale cars here.
That's a sale car. Did I bring my sale car? I didn't bring my sale car, but this is also something very easy to do, Daryl. There's no wrong way to make this. I showed you that. So you can have an option of doing it that way. You could use your cardboard. And what I've done before is taken the cardboard and taken a jumbo craft stick, one of these like tongue depressors, they used to be called. Mm-hmm. And I'd cut the bottom off straight. And then I put it on a plate or the cardboard, and I'd hot glue it like that so that it would sit upright. And then on the top here, I would put this plate, styrofoam plate, and I'd hot glue that right onto the craft stick and do it that way. Or I had here one of these takeout containers. Mm-hmm. You could use that. There's another way of doing it with just some sticks and putting it together. There's no wrong way to do this.
Awesome.
There are lots and lots of options that you have to make this. You can make different things. There's one with a little motor and propeller on it. So you don't have to have a fan. Usually what I have for these sale cars is a fan at the starting point, and we'll see how far it goes. But I wanted to show you this. Did I bring my motor? I don't see it here, but I might have it.
Marty, a quick question from some viewers are asking, what should they search for, like on Amazon, to find that airplane? Do you remember the name of the brand or?
Just type in 17.5-inch styrofoam plane, and you will find it.
Great. I'm going to type that into the answer box, and I'll make it a public answer so that you guys can find it, hopefully.
So here's one of these cars that can be used for anything, and you could attach, have this on a little piece of cardboard or something and spin this around with a little motor. Okay, this motor I also got from Kelvin.com, motor and propeller. So these are fun things like in that picture. You can get a little motor and a little propeller and a little battery and make your sail car that will continue to go until the battery runs out, which is quite some time.
Awesome.
So this is a fun thing you can do, sort of an alternative to the sail car.
Great.
So there are lots of different batteries. This comes with a little black holder so that if you're gluing it on, you're not gluing it, using hot glue, and the hot glue gets inside the motor and then it stops working. So it just snaps on here like so. That's what it looks like. And so, I don't know if you can see it better that way. Anyway, this.
Oh, yeah, let me bring this up bigger. There you go.
Okay, so that's what it looks like. Okay, can you see it? I don't know. Mm-hmm. You can see it better that
Further
way.
back, it'll be a little bit more in focus.
Okay.
There you go.
And so you just pop this in, pop, and it's in, and you glue on this part so you don't glue the engine and destroy your motor.
Awesome.
So that's another thing you could do.
So you said, I'm going to
Okay.
let them know too, so you can find these parts on Kelvin.com.
Kelvin.com.
Great.
Okay, let's start doing this. This is one of my favorite things. I have lots of favorite things. So this is called a piezo popper, P-I-E-Z-O. And it uses force or pressure to make a spark. So I'm going to hold this up to the camera.
It's
and
more in focus. A little bit
more
further
in
back.
focus back. And when I press this, did you see that little spark? Did you see that spark? It's a little spark.
I think it's kind of hard to see on the camera, but yeah, I can see it in person
Let's
here.
see, I'll do it against the table. Oh, I see that little spark.
Yeah.
Do you see a little spark? So there's a little spark, and you probably don't know what this is. This, did you see it?
So you're saying the physical pressure of pushing this is what's making that little spark.
That is correct.
That's awesome.
So I'm going to take 2 drops, 1 or 2, 2 drops of alcohol.
Okay.
And put it in this. This is an old film container. Back when I was a boy, they had film. You didn't have digital cameras.
A viewer says, Willow says, I can't see it. I'm assuming the spark. It's very, very small, Willow. It's hard to see, even up close. But those 2 wires there, when he presses the button, they're making a little tiny spark is jumping in between. It is there. It's just hard to see on camera. I know.
And now I'm holding this in my hand and taking the liquid alcohol that I had and changing it into a gas. Alcohol, do not drink. And then
Science alcohol.
when I put this in here, now I might have put too much alcohol in. If I put too much alcohol in, it's not going to go. But if I press this, this is going to make a loud noise.
Okay, I'm ready.
Are you prepared?
I'm prepared.
Are you prepared?
Point it away from the camera.
Okay, we'll go like this. And I just, whoa!
Wow.
I've seen this go like 30 feet before.
That was way louder than I expected.
I prepared you. I tried my best to prepare you, Corey. So that's a couple of drops of alcohol in this old-fashioned film container, and that little itty bitty spark made it fly. And you know, this is exactly what happens in a car engine. You have a fuel, not alcohol, but gasoline, and you have a spark, and that spark burns, and it pushes part of the engine down,
pressure.
and then that starts to turn, and that turning motion gets sent back to the wheels, and you're moving. So this is the same idea that a car, gasoline car or motorcycle or any type of engine has, and that little spark can burn and make a big noise.
That was awesome.
Yeah, I thought you'd enjoy that.
Let's see. Aubrey says, again. Mackenzie and Denali asked, where did you get that? Is this something you can buy too, or did you have to like make this or?
Well, the piezo popper, you could look for it online, P-I-E-Z-O. Then P-I-E-Z-O.
P-I-E-Z-O, okay.
It's called a piezo popper, and it uses pressure to make a spark. And then the other is just called plastic film canister. So that's what, in the old days, they used to have film cameras, and you'd have to open up the camera in a dark place and put the film in. And then every time you took a picture, you'd have to advance the film. And then when you're done with the whole roll, you send it away somewhere or bring it to a drugstore and get back pictures. And oh my gosh, what a pain that was compared to what we have now digitally.
We were still doing that when I was a kid.
Yeah. And then, you know, you don't like the picture. Okay, erase it, try it again, smile, you know, and that's what we do now. In the old days, you didn't know what the picture looks like.
Yeah.
Until you get the prints back.
Maybe the next week or something.
Yeah, yeah. And if
Some people still do that, but it's not very common anymore.
it's not very common. And sometimes, if you didn't finish the roll, you still have 12 more pictures. Well, we're going home now. That could sit in your camera for a couple of years. You don't know until you get the pictures back.
Yeah.
Anyway, that was a fun thing. So I just put 2 drops of alcohol. Now, the alcohol that I use is called denatured alcohol.
Mm-hmm.
You can get that at the hardware store or anywhere. Isopropyl alcohol, which is a kind of rubbing alcohol, is
like you could use for like an injury or something,
right?
Or a cut.
That would also work. But remember, I only used a drop or 2 because if you have too much, there's not enough oxygen, and it's not gonna pop. So
is the alcohol in there? Does it kind of, you want it to be more like? Is it actually going into like a gaseous state?
If you'll notice, I was holding it because the heat from my hand will change that liquid alcohol into a gas.
Mm-hmm.
That's what I want. I don't want a liquid alcohol. I want a gas, because the gas will ignite or explode so much easier.
But if it was like full of alcohol, putting a spark into that wouldn't probably do anything.
It needs the correct mixture of oxygen and fuel. Just like in a car, you could flood the engine.
Yeah.
Then, you press on the gas too much and you get too much gasoline inside the engine, not enough oxygen, and it won't start.
Mm-hmm.
So same thing with this. 35 millimeter film canister, piezo popper, a couple of drops of alcohol, and you will wake up your neighbors.
And that denatured, that means that's not drinking alcohol.
Right. It's 90% or something like that drinking alcohol, but people don't want you to go into the hardware store for your, you're having a party, go to the hardware store and get some alcohol. They add something to it. They add a poisonous alcohol to it, and that changes the nature of the alcohol.
So it still works for things like a wound or for a science experiment.
Right.
But nobody would drink it. It would make them sick.
It would make them very sick or kill them. Yes.
Right.
So that's denatured alcohol, or the isopropyl, or the rubbing alcohol. Anything like that is fine. There's one kind of alcohol they don't sell they don't sell it except for chemistry uses, and that's called methanol or methyl alcohol. And that is very dangerous stuff because that won't burn, that will explode.
Okay, even that much?
Even that much.
Good to know.
I'm going to show you this one. This
not using that
is one of my favorite things. This is a 5-gallon water bottle that I put some alcohol in. And then I turned it upside down and let all the excess alcohol come out. And I'm going to put this right here. Corey, I'm going to let you do the honors here.
Okay. Am I going to want to cover my ears again?
Nah.
All right. Here we go.
So there's a match.
Okay.
Light the match and then light this. And then what I want you to do is bring this right over there.
Okay.
So you can put that down.
Wow.
So feel how warm that is.
It's very warm.
Yeah, do you feel it over here?
Yeah.
That's warm.
Wow.
And you might notice, no, I don't see it here. Sometimes you can see a little moisture around the edge. Oh yeah, here you can see it. Can you see the moisture there?
Oh yeah, it's almost like somebody like when you breathe on a window or something.
Right, so there's a little moisture there. I don't know if you can see it there at home, but this moisture is caused by, yeah, I think you can.
Yeah.
So there's the moisture. There's not, look at that.
We're getting a little bit of reflection from the green screen, so it's kind of going invisible, but there you go. I think you can see that a little bit.
Anyway, that moisture is from the alcohol. Alcohol has, among other things, hydrogen in it. And when the hydrogen in the alcohol combines with the oxygen in the air, you get water. So this is water that you just made by burning the alcohol. So what I did is I took a little bit of a few drops of water, maybe a half ounce of water. I'm sorry, a half ounce of alcohol, and put it in here. And then I have a beaker. You probably don't have a beaker like this at home, but anything will do. And I turned it upside down to let all the excess alcohol drain out of here. Because again, you don't want too much alcohol. Too much fuel is not the best combination. You want just a little.
One person's asking if we can bring it closer to the camera again.
Sure.
Yeah, so you can see right here, part of it is totally clear. I know it's hard to see it a little bit because I'm going to turn the green screen off for a second so you can see this better. Okay, so green screen's off for a second. So you can see right here that in some parts of the container, it's still totally clear, but right there, you can see sort of a little bit of like condensation. You can actually see a bit of a handprint here. This is Marty's handprint from where he was holding it. But there's moisture on the inside of the bottle there. And that's from the chemical reaction of the heat and the alcohol made the water as a byproduct.
Right. Alcohol and oxygen burning will make carbon dioxide, and it will make water. As a matter of fact, you might have seen planes high up in the sky, and it's leaving this trail behind it. That's called a contrail. You might have heard the term contrail, C-O-N-T-R-A-I-L. And that stands for condensation trail. Because when the plane is high up in the air, it's doing the same thing with its fuel. It's burning it in oxygen and creating heat and carbon dioxide and water. And the water comes out of the plane, out of the engine, but it's so high up that that moisture automatically turns into a little cloud. It condenses or changes from a gas to a liquid. And that's a contrail.
Can I point out something else that I noticed? And for all of you viewers of James's space science class, the next time you're in space science, you can tell James that you saw Marty and Corey do this experiment, because I don't know if you noticed, but I saw it. He was holding the bottle, and when I lit it, it suddenly went like this.
Yes, it did.
And I think, correct me if I'm wrong, but creating all of that heat and that release of force, we invented a rocket there for a second.
That was a little rocket. As a matter of fact, I have a picture of a 5-gallon container. Let's see if we can find it.
We'll come back to that.
No, we'll get there.
Oh, there was that plane again.
And a rocket balloon. Yeah. Rocket balloon.
We're jumping over a bunch of stuff.
Yep,
Sorry.
there it is.
There it is.
Okay, so you can put it on a larger cardboard. This person has it on a skateboard.
That's a great
And
idea.
it's taped down, because otherwise the 5-gallon bucket will go flying, and and not so much the skateboard below it. But that's a fun thing to do.
But I saw in your hands it was pushing so hard.
It was going that way.
If it's like a solid container, there's only one place for all of that force to be released,
Right.
which is out the open end, which is the same way the rocket works.
Exactly. And it's the same way an airplane works. Airplane engine, same idea.
Marty, by the way, we have 6 minutes left, so we'll probably have to pick which things we want to show in our last 6 minutes here.
Which things? Okay, I'm going to show you this one. This is something you could do today.
This one, Code Hanger Catapult.
Coat Hanger Catapult.
Awesome.
So what I did is, with just a little stretching, I took this coat hanger and made it into a slingshot.
And we'll show this bigger.
Right there. And there's a rubber band going across here. And now I take my marshmallow. I let my marshmallows harden a bit.
Okay.
Because they last longer, and I have less students running into the lab eating them.
That's not as squishy as a marshmallow usually is.
That is firm.
So you just leave this out for like a few hours or days, and it'll.
Sure.
Is it the moisture is evaporating out of it a little bit?
Yes.
Okay.
So I take this, and you can take, I've had this one go about 30 feet. And you can go.
Here, we'll try to go straight up, then maybe we'll catch it.
Oh, it's going to hit the ceiling.
Yeah. Oh, it's gone.
Okay. Well, if I was going to do that, I was going to try and hit Isabel, but that's not going to happen. So anyway, this is really easy. Let me just give you this is the kind of rubber band that I use. This is the size.
It's like a binder, you know, it's a bigger one. You get that from like Staples or an office supply store.
7 or 8 inches, something like that.
Don't try to do that with like a little one. It'll just snap.
Well, you'd have to snap tie a few of them together, and that would probably work. So if you have the smaller rubber bands, you just tie them together and put them on, one on each end, and let her rip. Cool. And you can have fun with this. Oh, here's something fun you could do. This, I have to have a picture of a rollback can.
Yeah.
So this.
There's the coat Hanger Catapult. There's that plane.
Yeah.
There we go.
So this is just a can. This is an old peanut butter can, but you could use any can. I like to get them large because then I string a rubber band from one end to the other, and I put a weight on there, and when I roll it this way a little bit, you'll notice, I don't know if you can see it with the spring here.
Yeah, like the rubber band's kind of winding up in there.
Yeah, the rubber band's
probably show. So there's 2 holes here, and the rubber band is going through both of them, and there's 2 holes on the other side. I think if there's only 1 hole, it might not wind up the same way. We definitely want it to wind inside as you turn it. Well, this is just 1 hole here. Oh, okay. But I have it attached around a toothpick, so it's almost like it's split. Right, the end has to be able to stay in place. It can't just be punched through where it just keeps on turning with. Right, and that way, once you wind it up and I roll it, you can't see, but it's gonna, I roll it and it comes back. You wanna? I got a surface here we can use. Okay, let's hold this up on here. So I'm gonna roll it just a little and it comes back. I'm gonna roll it a little more and it comes back. And that's roll it this way and it comes back. So what is the property here? What is it doing? Well, it's our old friend stored energy and motion energy again. There's a round up rubber band, as you know, is stored energy. And so the stored energy in the rubber band wants to unwind. The weights are just holding it down so it stays wound up. Yeah. And then it's unwinding and changing into motion energy. That's awesome. That's all it's doing. Cool. We have about 1.5 minutes left here. Okay, I'm going to show you this. This is these CO2, carbon dioxide chargers. This is one brand. You could get them, I think, on eBay or Amazon. Amazon. And so they look like this. Oh, these go into, like, I've seen these like in a whipped cream can. Right. Yeah. Or to make seltzer. Seltzer is bubbly water, carbonated water. Or I bought this, but you could make something like that with these wheels and drill a little hole into a piece of wood. And then you could just tap this with a nail and a hammer perhaps, or something like that, and stand back because these things will go flying. So this is basically a little rocket again. This is full of like pressurized. It's stored energy. Yeah. It's stored energy. So if you make a little hole in the end, there's only gonna be one place to release and it's gonna take off like a rocket. Right. I'm gonna show one more thing. I know we're running out of time, but here's our old friend, handy dandy battery. Would you okay? And if I attach this to one end and that to the other end and give it a little turn. So this is a little motor. Oh, and it's a motor unless the one end comes off. And then this is something you could make. This is a little called a DC. DC is direct current. That's what batteries are. Your wall socket is AC, alternating current. That's another webinar someday to explain what the difference is. You can get electric motor kits like this on Amazon. Right, Amazon or eBay. It's called the DC motor kit. I put this together myself. This was like $15, and it's very easy and it's very fun, and it teaches you all about motors and electricity and that sort of thing. That's awesome. So please watch this video again and find out what you want to do, and you'll have the information to buy it and make it. And I hope you have fun with it. I hope you learned something.
And remember, curiosity is the cure for boredom. So if you're bored, find something to be curious about. I think that's my sign off.
Awesome.
Isn't it? So
thank you guys for watching today.
Have a great day, and we'll see you next time.
Yeah, we'll be back next week with another Science with Marty class. And tomorrow we have drawing at 10 a.m. We have space science with James at 11 a.m. And then we're going to have our book club at 1:15 in the afternoon. All of those are in Pacific time. So we'll see you then.
All right. Thanks for watching. Bye for now.
Bye until next time.